Hello, hello. Hey guys, I am Maxi Tester and I am happy to be here on CypressConf 2025. And in this conference, I will share the talk called In a World Full of Bugs via Deadpool, Cypress and Design Principles Unlatched. So let's see who is Maxi Tester. I'm going to talk a little bit about myself. I have been 15 plus years in the IT areas as system analyst, QA automation engineer, rolling like leads manager, also entrepreneur. You can see in this slide my social media. You can follow me. You can follow my LinkedIn, Facebook, my YouTube channel, and also my email if you want to ask something. So let's see the agenda. The agenda starts with what is the design principle? Let's see what are the solid principles, the dry, KISS, YAGNI, and Law of Demeter principles. And then we will see a demo. So what is the design principle? A development design principle is a guideline that or rule that helps teams make consistent, informed decisions throughout the design and development processes. These principles promote efficiency, consistency, and user centricity, and are often used in areas like software engineering to create maintainable and extensible systems. Let's start with the solid principles. Solid principles consist of 5 object-oriented classes design principles. They are a set of rules and best practices to follow when designing a class structure. These 5 principles help us understand the need for sincere design patterns and software architecture in general. That's why I believe it's a topic every developer and tester should learn. You can see in the slide, we have an acronym SOLID, and let's start with the first letter, S. Means single responsibility principle. O, open close principle. L, list code substitution principle. I, interface segregation principle. And D, dependency inversion. The solid principles were first introduced by renowned computer scientist Robert G. Martin, also known as Uncle Bob, in 2000 paper titled Design Principles and Design Patterns, where he outlined foundational concept for object-oriented design. But the solid acronym was coined later in 2004 by Michael Fetters to create an understandable, readable, and testable code that multiple developers can collaborate on effectively. The ICQB emphasizes changes on it. The S that we have here still be the same, single responsibility. But the O that you can see in the slide, it's instead of open close, they change to extension. The L remove the L from list substitution and change to replacement. And the I interface segregation, they call it component segregation. The D is still the same, dependency inversion. I hope in the future the ACQB don't change the name and just maintain the OLDI acronyms as is. Let's see the benefits that we have if we use these kind of principles. Create effective software that fulfills its purpose and is robust and stable. Write clean and flexible code that adapts to change, code that can be easily modified as needed and is reusable and maintainable. Enable scalability, software that can be expanded with new features quickly and efficiently. So, among the key goals of applying these 5 principles when writing codes are ultimately to develop high quality software. In this context, the application of solid principles is closely related to the understanding and use of design patterns, which help us maintain high cohesion and therefore low coupling in software systems. Software cohesion refers to the degree to which different elements of a system work together to achieve a better result than if they operate separately. It deals with how we can group various software units to form a larger, more meaningful unit. Coupling, on the other hand, refers to the degree of interdependencies between two software units, where a unit may be class, subtabs, methods, module, functions, libraries, etc. Let's start with the first letter in the solid principles. Single responsibility. The single responsibility says a class should have one and only one reason to change. Imagine Deadpool as part of superhero team. Surprising, I know. While he's known for the being chaotic and breaking the fourth wall. Let's assume he followed one rule strictly.
I'm the guy who handles eliminations, not the one managing logistics, fixing tech, or negotiating peace.
In a well-structured superhero team, Deadpool is in charge of combat and eliminating enemies. Colossus handles defenses and moral guidance. Negasonic does explosive attacks. Whistle provide intel and gadget. If Deadpool start doing everything, hacking planning missions and giving motivational speeches, the mission will fall apart. Now let's see this principle in simple code lines. In this case, we have a class called login page with methods type username, type password, submit. We're using the design pattern called fluent interfaces. We need to know that design principles and patterns could work together in a very, very good way. So in this case, login page, using the design pattern also, page of the model, login page only handles login, not assertion, user creation, or dashboard or validation. That's the only responsibility based on the login page, what you need to do. Page of your model accomplish this specific principle. Now let's move to open close. That says you should be able to extend a class behavior without modifying it. Imagine Deadpool has a customizable weapon system, because of course he does. It's a start with basic swords and guns. Now, when he wants to add grenades, katanas that shoot bullets, or a chimichanga launcher, he shouldn't need to modify his original combat code. Instead, he just plugs in new weapon module.
I'm a mercenary, not a software engineer, but even I know not to touch code that already works. Just strap on a new weapon, baby.
Well, we have this specific constant method called validation strategy. We have admin, guest, and default. Those are kind of users that has a validation that says should be visible. And I have a function that call validate users, and we can just create this user by default. In this case, we will use the default user if we don't have admin or guest, and just instances the specific element created. But we're still modifying the validation strategy object. So in this case, validate user doesn't need to be modified. We only need to use or add in the value in the validation strategy which element we need. Maybe an invited user or maybe a normal user or whatever user you want. And I think the question could be why if this principle says you don't need modify, in this case validation strategy, we need to add items. But well, the truth is the validated user is a specific element where you don't need to add. Open close principle means you should be able to extend behavior without modifying existing source code, especially closed modules like shared stable testing component. So if validation strategy in our case is part of a central class or core module, modifying it doesn't violate the OCP. OCP doesn't mean never change any file. It means the part of the system that are considered stable or shaded should not be need to change. When new behavior is added, you isolate change to extensions or plugins. You are respecting the OPC. Let's move to list scope substitution that says derivative classes must be substitutable for their base classes. And this name is based on the last name of its creator, Barbara Liskov. That means that objects should be replaceable with instance of their subtypes without altering the correct behavior of the system. In other words, if a program uses a certain classes, it should be able to use any of its subclasses without affecting the program functionality. Imagine you have got a class hierarchy, mercenary, for example. This is the main class or the parent class. The base class with a method that we can just imagine a method called eliminate target. And it had subclasses Deadpool, Domino, Cable, and Buff, agent of Hydra, pretending to be a mercenary. All real mercs like Deadpool, Domino, and Cable can eliminate a target, each with their own style. But Bob, he panics, run away, and throws his gun at the target.
Look, if you subclass me, you better bring the same merc energy. If you flinch, panic, or throw your gun at the bad guy, you're not a Deadpool, you're a liability. That's Liskoff, Cupcake.
In the example that you are seeing, we have different classes. The parent class called user that has a login method, an admin user and guest user. Both extend from user. We're using inheritance, and each class or subclass has their own behavior. So, for example, if I instantiate the new user, I can call the method login. But what if I instantiate instead of user, I instantiate admin users? So in this case, I also call the login method. But if I instantiate get user, it's the same result. I instantiate the login method. So I can use the parent or the subclass and the behavior will be the same. That's list cup substitution. Let's move to interface segregation. In the four solid principle, Uncle Bob suggests make interfaces specific to a particular client, or more specifically, make fine-grained interfaces that are client-specific, meaning for a specific purpose. In this sense, according to the interface segregation principle, it's better to have many small interfaces with few methods than to have single interface that force the implementation of many unused methods. Deadpool was forced to attend press events, rescue cats, and file reports, things that he absolutely hates. He just went to fight bad guys. But splitting superhero duties into smaller contracts, he only took what fit him. That's interface segregation. Give classes only what they need. No extra fluff, no wasted effort.
Stop making me sign up for things I don't do. Want to save cats? Call Spider-Man? Need a good quote for the press? Try Captain America.
In the example that we have out utils, we have login as an admin, login as a user, reset database, and send telemetry. The last two, they are not needed in our test or required in any part. So if we implement this contract, we need to call those specific methods called. But if we don't need it, we will just put something that is not useful. Instead, we can split into, for example, login helper, where we have the two methods that we absolutely need, and other that could be the test setup and monitoring. With that, we only use what we need when we need. Dependency inversion. Robert C. Martin recommends high-level modules should not be dependent on low-level models, depend on attractions, not on concretions. Both actions should not depend on details. Details should depend on attractions. The goal of dependency inversion principle is to reduce dependencies between code modules, that is, to achieve loop coupling between classes. Deadpool Mission Planner doesn't care how the job gets done, just that the target is neutralized. So instead of saying words like use a sword always, he says use any weapon that implements the kill bad guys strategy. Now, in this case, Deadpool could use swords, guns, explosive tacos, even chimichangas cannot get the jobs done. If he ever wants to switch weapon, he doesn't change the mission plan. Use the tool behind the scenes.
Tie your code to the job, not the toy. That way you can swap swords for grenades without rewriting the whole movie. That's dependency inversion, baby. Boom.
In our code example, we have our login page when we have the same methods previously created. Look at this. Now we have another web page or page class called dashboard with a specific method that this class needs. When we use in a test, we only need to call login page and dashboard page. And the test doesn't need to know how they work behind the scenes. Only need to know they need some methods in order to execute this. That's dependency inversion. We don't need to know how it's built. We need to know what we need. Don't repeat yourself. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. It's a principle of software development that aims at reducing the repetition of patterns and code duplication in favor of abstraction and avoiding redundancy. Popularized by the book The Pragmatic Programmers, the DRIVE principle states that every piece of knowledge must have a single unambiguous authoritative representation with a system. Using this principle, logic or algorithms that have certain functionality should only appear once in application. Deadpool has one finishing combo that works: Colossal draws fire, Negasonic stuns, and waits clean up. If they tweak the combo, they change it once in the playbook, not in five places. Fewer repeats, fewer who chained what. Surprises.
Write it once, love it forever. Unless you're into pain, then repeat yourself like a bad sequel. Me? I like my code like my jokes. Sharp, reused, and deadly.
In this code, we have a username and password, and we need to clean and type every time. So we are repeating, and in the future, if we have a form with more input items, we need to do the same, clear and type. So instead of, we can add a command that says clear and type with the actions clear and type. So in this case, we only need to call one specific method for the number of forms or inputs in the form that we need. In this case, the username and the password. We are put it all together. If you want to shine in using the Fluent interface, you can use the method that you're seeing in the slide. Clear and type, and you can just start shining elements under. In this case, get user, clear and type, and then you can define them and start on it. In the first case, as you see, we have a method with only two parameters. We are not specific what the parameters are. In the second, we are chaining them. First is the item to locate. The second is the action to do over it. KISS. KISS principle, which stands for keep it simple, the word that I don't want to say. And we can use some variations like keep it short and simple, or keep it super simple. The term was first used in the US Navy and is thought to have been coined by Kelly Johnson, who was the lead engineer at the Lockheed Skunk Works. Johnson told the designers at the Lockheed that their design should be simple enough to be required by a man in a combat situation with only some basic mechanisms, training, and simple tools. So, for keep it simple, we can say it's better to maintain simple solutions rather than making them complex. Now, let's see what we'll do with Deadpool. Imagine that we're in a mission plan. Whistle finds the door. Negasani opens it. Colossus shields. Weight slices. And no 12 steps, hates, or nanotext origami. Simple beats clever when both fly. And it was easier to debug my fight.
Why build a rocket-powered chimichanga launcher when a sword gets the job done? Keep it simple, Cupcake. Less code, fewer regrets, and more time for tacos.
In the example, we have a function called select option from dropdown. We need the dropdown selector, we need the option text. You can see we have all the steps in order to select an item from the dropdown. But why we need to create this complex function if we only, for example, need just 3 steps to do it? Click, and verify the text. That's it. You are keep it very simple. Or in this case, we can reduce obviously the function to only those actions. That's it. Better, consistent, and simplest as the first version. You aren't gonna need it. YAGI stands for you ain't gonna need it. It's a principle from software development methodology of extreme programming. This principle says that you should not create features that is not really necessary. This principle is similar to KISS principle. Once that both of them aim for a simple solution, the difference between them is that YAGNI focus on removing unnecessary functionality and logic, and KISS focus on the complexity. Ron Jeffries, one of the co-founder of the Extreme Programming, once said, "Always implement things when you actually need them, never when you use forces that you need them." In this case, Weisel proposed jetpacks, time travel grenades, and anti-alien foam for a bank job. Deadpool packs, katanas, and ammo build and carry only what's today mission needs. Future, you can add the weird stuff when it's real.
Planning for a zombie apocalypse in your code, unless your app runs in The Walking Dead, stop overthinking it. If you don't need it now, don't build it. Save the drama for your therapist.
Let's see the code example. We have the users, we have admin, guest, support, and QA with different element locators. But we don't need, in this case, for example, the support and the QA because we don't have implemented. Add roles only when they actually user in the scenario or test. In this case, we remove support and QA and just keep the real needs in the moment. We don't need any other information. When we need it, we will add it. Law of Demeter principle. The law of Demeter, also known as the principle of less knowledge, it's a software development design principle. It's a design guideline for a software developer because this is the rule for designing object-oriented system. And it says a method of an object should only call methods and objects that are directly related to it. It was proposed by Ian Holland of Northeastern University in 1987. It was named Demeter because the style rule was perceived while working on the Demeter project and strongly inspired by the Greek goddess of architecture, Demeter. For some people, they mean Demeter as grow software in small steps. Here's the main concept of LOD. Each unit should have only limited knowledge about their units, only units closely related to the current unit. Each unit should only talk with its friends, don't talk with strangers. Only talk to your immediate friends. Wait Ask Whistle for Intel. No Whistle's laptop databases API. He has Colossus for cover, not Colossus to ping Negasonic drone firmware. Work with direct teammates and clear interfaces. No poking 3 layers deep.
I talked to Weasel. Not his mechanics, dentist, dog walker. Fewer middlemen, fewer bullets wasted. That's how you keep your code and your missions tight.
Let's see this code. The test directly navigates to nested structure, model, footer, and button. If the model's doom structure changes, the test will break. everywhere. There's no too much about the internal layout. It's very tightly coupled. Introduce a facade, like we have in the image, for example, delete model or cancel and is visible that expose only what the tests need and implement when you need it. The test talks only with the delete model, its friends, not inner elements. Dumb structure is hidden behind a clear interfaces. Follow the law of Demeter. No chaining through multiple layers. Now it's time for the demo. Let's move on to Visual Studio. Hey, we are right now in the demo. I want to share with you. The demo is on G Sanchez M CypressConf 2025. You can download the complete project. Let's see the structure of the project. I have 3 folders. The Cypress is where we will have all related to all test cases. I will talk about locators and common. Those folders are related to classes that you can use not only for your specific testing project. You can share if you're using Cypress in different projects. So those are reusable. Common is the reusable. And locator is something that you can share. And I did this coupling from the Cypress project because the locators you can use not only for the web UI, you will use, for example, if you have a mobile project. And I will show you why this is important. Also, I have my m file.m where I can just specify different environment variables. And my Cypress config file, yeah. In this, I have all the configuration that I need in order to start looking and working on my project. In this case, something that I want to share with you is the logger. I am using this logger from a library called Pino, and I have all my configuration here, the platform, the log level, and just all the information that I need. And in this case, I am not using console log, I am using logger.arrow or logger.info, all the log levels that you specify. Let's start with these locators. I am not using specifically the page object model. I am using more some pattern that is called screenplay, but not complete screenplay. I'm not using the actor. I am not using the question because for me the questions are more related to the user and the ad. And I try to change to a tester, QA engineer vision. Instead of questions, I have validations. We're validating something into the application. And instead of page subject model, we talk about it. It follows the single responsibility principle, but when you have these extensions or big pages where have a lot of elements and you need to add a lot of methods that interact with your application, it will create a spaghetti code. So in this case, I implement some it's another design pattern called proxy pattern. It's a pattern that I personally implement in my project because I love it, and I will show you why. This is my locators, my elements. I have my username specifying what kind of web element is, an input button, link, or whatever. You can just specify, for example, here label button, and those are input. What's the most important part here? As I mentioned, we know Cypress work only with web, but what happens if you are mixing between web and mobile? You can use maybe WebDriver.io with Appium or other tool you want to use. So in this case, this pattern will give me the ability to have the web element. And maybe you ask why you have desktop unresponsive. Yeah, that's because some frameworks like React have some items that you can see in visual way, that when you have the full page, the elements are, for example, I don't know, uh, menu items, no? And when you resize, when you perform regression and you have the same items, but the locators are different, are completely different, because that's something that, in this case, React could help you. could create in that case. So if I have a different locator for desktop and responsive, in this case it's the same. It's just to, for example, it's just to use this example, and I can use whatever element that I specify. This will be in the future my local variables, my environment variables. So I can run into my local and also in my CI/CD. Maybe I want to run it in full version in the full screen, so I need to use only desktop. This will be my variable, and it will take automatically the locator that he needs. Or I want to run responsive, so it will take automatically the element, the ID of the element in that case. As you can see, it's something that is implemented right now in the project. And what are the benefits? Normally, we have the web and the mobile, and are the same views with kind of little differences. So in this case, I can just do something like this. Imagine that I have mobile. I can use the mobile variable and just call it. And then instead of using another page classes, I can just put here, and based on the variable that I'm sending, obviously you can do it in parallel, it will take automatically. But we have all the elements in one place instead of having multiple classes. So yeah, that's the first part of the locator. The second is the common classes, common libraries that will help not only my testing project, and if I want to share with other team members, you can share, and it's something testing agnostic, doesn't relate to the testing, to test a specific platform, is something related to the test in general. So for example, let's start with these action classes. But before, this is my single responsibility. As you can see, single responsibility is not only for classes. I am doing my own responsibility for this file. It's only to take care of my elements. And I will have other classes that I can use. So for single responsibility also, I have a lot of classes here that could take base on that following. For example, click until visible. This specific class has the ability to only click when the element is visible. I don't have any other class that gave me, and also the click, and also the get text or whatever. In some cases, in Cypress, we have the command class, and I saw a lot of times in the command class, the people add all these kind of actions that you can follow, and you have a class that has thousand and thousand of line of code. That means spaghetti goes and break all these design principles. So in this case, each class has their own responsibility. Even you will see on our classes, and I will mention which classes implement this principle. And also, if we move to the open close, I have all these classes, action classes. As I mentioned previously, I saw in some cases, even if you go through my old repository for the 2024 conference, you will see the command class has a lot of actions, each actions in one specific class. So in the command class, in order to start calling. But in this case, the idea is to start adding elements, adding actions as you need it. So we are following the open close principle. And we have this class called action registry that it will automatically register, well, take care of the register classes that we have. And we have this register default. This register default is where I put all the classes that I need to be work on it. The next will be list of substitution. List of substitution we will see here in my strategy. Look, I will mix between design pattern strategy and also the list of substitution. I have a list of elements like like a menu. It's a menu. You have the logout, reset all, and all these kind of menu items. So in this case, I have two strategies. The one is for select by the index of the all the list element that I have, and the other is selecting by text. For example, the logout that I mentioned, or reset app, or go home, whatever. In this case, I have two strategies. And list substitution says, even if I use menu select by text class with the select method, or select by index, if I use the select, it will not behave different. It will work as expected. In this case, opening, I am using my strategies into a class called perform upper menu with strategy. I have all my tasks here, and if I go to perform with the strategy, I can see I have the mode. This is the default mode using text. If we use a strategy with the text, we can change to the index if we need it, and it will select depend on what strategy we are using. This specifically, and this is my test, it will select based on the parameters. Not, I don't need to change any other classes. The only change is the parameters. Easy, and automatically will take care if we need the strategy of index or the strategy where we use the text. Interface segregation. As I am using the screenplay pattern, this is task, something that I think is very useful because are tasks that the user will perform over the application. And validations, as I mentioned, those validations that I hear, my test validations are what I am testing, what I am asserting that is there in my page. So here I have my contracts. I have two contracts. I could create one interface that involve task and validation in the same interface, but that breaks my interface segregation. So for the reason I have my interface task called iTask, and that only take care of my task, and my interface validation that only take care of my validations. Then I can just start looking into my base validations, base tasks. So they are only working what they need. They need only that interface, it use them. Validation only needs a validation, so only use them. I don't need to implement other methods that I will not use. So the dependency injection that we see in these clusters creates a kernel. Here we have helpers because we will create something called run task and run validation. This run task and run validations will be called into our test cases. For example, here I have run validation, run task. I have another test class, and my task and my validation, and same for this other class, run task and run validation. In this case, I am not exposing what is the intention or what, for example, perform login does. Right, don't repeat yourself. If each class here implement don't repeat yourself. For example, this check if and check it. If I want to use them isolated, I need to use the locator and then the validation every time. Instead of I have this class that do all the logic inside. Or for example, click on element. Click on element needs to get the locator, and then I also have a little validation that will be visible, and the action. Imagine if I implement this in all my tests, I need to do the same, get the element, verify if it exists or is visible, and do the action. About KISS, keep it simple. Keep it simple, I have implemented into my test cases. So you can see I don't need to do more or start doing something complex in logic. I am just doing what I need. I need to do a login? Yes. I need to validate something? Yes. That's it. I don't need to do more. I need to start looking into other kind of validations. And even, for example, here I only recommend two. Two is the greatest number to do validation. I prefer to do only one, but I am just adding two. In this case, more than two, your test, you need to break it because your test is doing a lot of validations, and that's not the way. Here, look, actions, steps, don't do more complexity. YAGNI, when we have all this, you're gonna need it. Ideally, it's that I have some, for example, this click link. If I want to implement this YAGNI, because I am not in this case, for example, clicking on any link, I I can remove it because I, even I don't need to create the class because in this case it's not what I'm using. So if I have classes that I am not going to use, you can first don't do it, don't create them. If you're going to use, is when you need to create it. So that's the YAGNI. It will be for the complete project. It's more for a logic and class level. For law of Demeter, we are using facade design patterns. So in this case, it will help us to doesn't communicate with other things that we don't need. Here we need to call the pages that we have here, and the key, the element inside, then extract the element, then the action like click, like type, or whatever action we have, an argument if needed. So when we implement directly overall task or validations, we only need to call this specific element. Like here, we're using the UI instead of called side by side. And as my JSON and my elements, also my classes, are not my friends directly, I can just skip them. So my friend is the CTX UI, where I need some parameters, also values, but this is my direct friend. I don't need to know about others. I don't need to call with them. But yeah, that's implementation overall. The law of Demeter we will have here. Also in some validation would we need it. Not in all we have implemented because the logic in some cases is not needed. For example, here, but in cases like this where we have ctx.ua, that means we need it. And also I have commented last like law of the matter. There we go here. So this is the specification and how we implement the law of the matter on our project.
You survived a talk packed with sarcasm, explosions, and clean code. That means you're ready to take on flaky tests with maximum effort. Now it's Q&A time. Ask away anything but how to stop using console.log. That habit is incurable.
And remember, if we don't test the code, we will abandon it.
All right, folks, that is our session. And honestly, only Gilberto could make a software architecture flow like an action movie. So, as promised, Gilberto is here with us, joining for a live Q&A. And I know we have some questions, Gilberto, so we are going to roll through these. First one I think would be great for us to talk about here is from Leonard. If our team has not yet implemented these concepts, how much change would you recommend introducing at once? There's a concern that it might feel overwhelming for new team members or those in an onboarding process. So what do you think, Gilberto?
Absolutely. I have been implemented these patterns and principles on projects that a legacy project that they don't have it, but I did it in baby steps. The first step, for example, implement right. Dry is simplest, the simplest principle that you can implement. Maybe keys, start reducing, start splitting the stuff that you want, and then you can start with the solid. Solid, I think, since the implementation of solid is more complex, but also we have the screenplay, as I mentioned, pattern that gives you more like the idea of how to start looking into them. And other is don't try to do it isolated. So that means don't try to only implement open close. You can, for example, mix between single responsibility or open close at the same time. But yeah, you need to do specifically piece by piece. Don't try to remove the complete project or change the complete project. I always take some functionalities and then start working on it. If that works, then go to other functionalities.